Okay. And if you have a question, I do want you to just like, you're gonna have to just unmute and like ask because I may not be able to see the question come up. So what we're going to do is we're going to talk about absolute value functions. This is what they look like in their most complicated form. This A, you're going to find out on the next page, is really just, it's like a fake slope. In a parabola, when it's got like a 5 in front, it's not really the slope. It's growing 5 times as fast, but they grow at a very special rate. But since absolute value just are lines, it is like the slope. So it's going to be way easier to graph. Now, H and K are the vertex, and it's just the H part, ignoring the minus and the K. So we know what an absolute value looks like from the last worksheet. So I want you guys to just go corner to corner. So up to 6, 6 and negative 6, 6, and just get your V's in there. And then copy and paste it on the other one. The graph is the exact same size. So get that set up. And what we're going to do is we know our rules of transformation. So we're going to already apply that. And I forgot to have us write this. Girls, an absolute value function just looks like a V. That's all it is. So let's cut this, let's copy it or duplicate it. And we're going to, oh, I think it's going to freeze. All right, let's copy and hold on, guys. All right, so we're going to copy and paste, change your color, and we're just going to move this up 3 because that 3 is outside of the absolute value. It has nothing to do with X, so it's a vertical shift, and then we just leave it there. Where is the vertex of this? It is at 0, 3. And if you take a look, the 3's are in the Y position. Now, in the other one, we're going to still paste, and I'm going to make this one orange to match those. And this one, you can see it's got the +5. And if you remember, it is the opposite of what you want to say. So we're going to shift 5 to the left. We'd leave that. And its vertex is -5, 0. If you guys take a look at that absolute value equation and you just think, well, what would it take to make that absolute value part equal 0? It would take -5. That's why we're moving left. So here's a quick little reminder for everyone. It'll be right on this sheet. H and K are the vertex, and X and Y are any point on the absolute value graph. So what that means is when you're given a vertex and maybe you need to plug it into something, we only plug in things for H and K. X and Y are like points on the graph. They're different. They don't go in those 2 spots. Now, if you recall, a vertical shift is when we move up and down, all right? And that means you're outside of the parentheses. So we're going to move up K units if it has a +K, up K units, right? And so in that picture that they give the example of, we'd be moving up 5. And when it's got a minus sign, it's going to do exactly what you think. It's moving down K units, whatever that number is. And so in our example, we would just be shifting that entire absolute value down 3. But again, the H one is a little bit more complicated because you really have to remember that you're moving in the opposite direction. So if we have that, we're going to move H units right. That's what your shift is, right? And it's because it's X minus whatever the number is. And so if I just do X minus, what's left? Just the 8, right? So we're moving 8 right. But with the other one, we're moving H units left. And the reason it changes sign is because the original problem is a subtraction. X minus what number turns into a +5? The only thing that'll make that plus is if you have a minus minus. And so that's why it's -5. So that is a quick little refresher. I am aware of the time, guys, don't worry. But I do want you to get this part copied. Reflections, that's when you have a negative outside. I mean, yes, I know you can have it inside with the X, but we're going to talk about reflections over the X axis. If there's a negative outside the absolute value, or if the leading coefficient is negative, such as y equals negative x squared, they open down, okay? And it is a reflection over the x-axis. But I have a little note, and it's because reflections in the y-axis, that's what I was showing you earlier, they don't change. It says the reflection is the same picture. So you can ignore the negative inside there when it is an absolute value or a parabola, an x squared. And it's because they have an axis of symmetry. They have something that already provides a reflection, a mirror image. And again, just to have a quick peek, let's go and look. These are real reflections. The top one opens up, the bottom one opens down. But again, when we do this and we put the negative in here with the x and say, please do a reflection over the y-axis, it's the same thing as the red one was. Like they didn't change. They're both the same picture. And that's because the mirror images, they already are mirror images of each other along a vertical line. So there's only one other thing we need to know.